Hey everyone, welcome back to NexMEP, your guide to MEP engineering excellence. In today's video we are covering a topic that every electrician, MEP engineer, and engineering student must know: fuses and circuit breakers. What are they? How do they work? And most importantly, what is the difference between them? By the end of this video you'll have a crystal clear understanding of both devices and when to use which. Before we get started, if you are new here, hit that subscribe button and the bell icon right now. We post a brand new MEP video every week covering electrical, mechanical, and plumbing, and you don't want to miss any of it. Drop your questions in the comments below, I'll personally answer every one. Alright, let's get into it. Fuse versus circuit breaker. Let the battle begin. Here's our roadmap for today. First, we'll understand what a fuse is and how it works. Second, we'll look at circuit breakers, what they are and how they protect your circuit. Third, and this is the most important part, we'll do a detailed side-by-side comparison between a fuse and a circuit breaker across 10 key parameters. And finally, a quick summary to help you remember everything. Let's start with the fuse. An electrical fuse is a deliberately weak link in a circuit, a short piece of metal with a low melting point, often a tin lead alloy, that acts as a sacrificial protector. The mechanism is simple. Current flowing through any resistance generates heat proportional to I squared times R times T, Joule's law. Under normal conditions, the element stays cool. When a fault drives too much current through it, the element heats up faster than it can dissipate that heat, melts, and breaks the circuit, stopping the fault before it damages wiring or starts a fire. A few key points worth knowing. The fuse rating, example 5A, doesn't mean it blows instantly at 5.01A. It means it will eventually blow at that current. Fuses have a time current characteristic. A small overload takes seconds or minutes, while a severe short circuit blows in milliseconds. Before MCBs became popular, fuse was the main electrical protection device used in homes and industries. Now let's talk about the circuit breaker. A circuit breaker is an automatic electrical switch that protects a circuit from damage caused by excess current. When a fault is detected, it trips open to stop the flow of electricity, and unlike a fuse, it can be reset and reused. There are three types based on how they detect faults: thermal, overload, magnetic, short circuit, and abnormal condition in an electrical circuit where current flows through an unplanned path, electrical fault. Here's a clean structural diagram showing what's inside one. Here's a brief explanation of the diagram. Circuit breaker fault types, flow overview. The diagram shows the three types of electrical faults a circuit breaker protects against, and how it responds to them. The three fault types, top row. Overload occurs when too many devices draw current from a single circuit, exceeding its capacity. Short circuit happens when a live wire and a neutral wire come into direct contact, causing a sudden surge of current. Electrical fault covers issues like earth faults, insulation failure, or wiring defects that cause unintended current paths. The response chain, flow downward. All three faults lead to the same sequence. Abnormal current flows: the current exceeds the circuit's safe rated limit. Circuit breaker detects the fault: either a bimetal strip bends, for overloads, or an electromagnet activates, for short circuits, faults. Power supply switches OFF: the circuit is safely interrupted, preventing damage or fire. Now let's do the main comparison: fuse versus circuit breaker across 10 important parameters. Point 1. Working method. A fuse works by physically melting when excessive current flows, making it a one-time use device that must be replaced after every operation. It offers very fast protection against overloads and short circuits, which is its biggest advantage. It's low cost and suits older systems and small circuits, but fault identification is difficult and the need for replacement makes it less convenient with higher long-term maintenance effort. A circuit breaker trips automatically during a fault and can simply be reset and reused, making it far more convenient. It protects against overloads, short circuits, and, depending on the type, leakage current as well. Faults are easier to identify since the tripped breaker is visually obvious. It costs more upfront but requires minimal maintenance, making it the preferred choice for modern homes, offices, and industrial installations where it provides advanced protection overall. In short, the fuse trades convenience for speed and low cost, while the circuit breaker trades a higher price for reusability, smarter protection, and ease of use. Let's quickly wrap up everything we learned today. Fuse is a simple electrical safety device containing a thin metal wire. When excessive current flows, due to an overload or short circuit, the wire melts and automatically cuts off the power supply. It provides basic protection but must be physically replaced after every operation. Fuses were the standard before MCBs, miniature circuit breakers, became widely adopted. Circuit breaker is a more advanced automatic protection device. It trips instantly during abnormal current conditions and can be simply reset and reused, no replacement needed. Beyond overloads and short circuits, it also handles broader electrical faults, actively preventing fire, electric shock, cable overheating, and equipment damage. The core difference in brief: a fuse melts, a circuit breaker trips. A fuse is replaced, a circuit breaker is reset. A fuse gives basic protection, a circuit breaker gives advanced protection. A fuse suits older systems, a circuit breaker suits modern installations. In essence, both do the same fundamental job, protect the circuit, but the circuit breaker does it smarter, safer, and more conveniently. If you found this video useful, please give it a thumbs up and share it with your friends and colleagues in the electrical or MEP field. It genuinely helps more engineers discover this channel and learn these concepts for free. And finally, if you have a friend, a colleague, or a student who is learning electrical engineering, share this video with them right now. One share from you could change how they understand protection systems forever. Subscribe to NexMEP for a new video every week covering MEP basics, site practicals, drawings, and design tips. See you in the next video. Types of circuit breakers: MCB, MCCB, ELCB, RCCB, everything you need to know on site. Don't miss it. Keep learning, keep building, see you there.